So, the question I have for you today is, wouldn't you like to forget about the database? You probably already saw this slide. We all know that Ruby has an absolutely awesome community. We have awesome tools to work with, makes our lives easier. We have a lot of fun doing it. I think that's actually a really important part of working in Ruby, is that MOTS wants us to have fun. I think there's a lot of stuff that we do, that we have to do all the time. We're not having as much fun as we could. I think that comes around databases. So I have the word SHOEHORN up there. I think what we do every day, millions of times a second, well, maybe not millions of times unless you're running Node or something, is we have objects, and we need to persist them. So we tear them apart, we shove them over the wire into some relational database, document database, something that was fundamentally not meant to store objects. Now, we love objects. We love the DSLs we write, make it very comfortable to work with these things, and translate business language over to technical language. We have a lot of fun doing that. But I'd say that some of these query languages, like SQL, even having to know JavaScript for MongoDB, weird pattern matching stuff for Redis, it's not really what we want to be playing with. So again, these databases are just not really meant to store objects. And that leads me to talk about the object relational impedance mismatch. That's kind of a big term. Basically what it means is that we have one world over here, and we have this disconnected world over here, and we have to get them to talk. And so we do that by using tools like Active Record, Mongoid, stuff like that. And you find in the slide later, but I'd encourage you to go read these articles. They're pretty fascinating. So my brother is actually learning how to program, and he doesn't have any experience. I think he took one SAS class, the statistical SAS, in college, and he's very excited to learn how to program Ruby. But the one thing, as a Rubyist, that I kind of dread telling him about is how to save his objects. If you think about just a normal request, we have to go out to the database, we have to query it, to build it back up, we have migrations, we have to maintain these databases, and it's kind of a pain in the ass, really. So this impedance mismatch makes it really hard for people to learn how to write systems in Ruby. So impedance mismatch is actually described by this term PORO, plain old Ruby objects. I despise this term because if you think about it, we have this term, which is really what we want to be dealing in, just objects. We have it because our normal day-to-day objects are active record objects, or they're objects, or I'm sorry, models that we have to persist to Mongoid. And so we think about the objects themselves in those classes in terms of the database that we store them in. And I think that's really unfortunate. So if we think back decades, older than me, older than a lot of us, there's Smalltalk. Ruby is largely based on Smalltalk. So Smalltalk has the notion of an image. I kind of think of the image like this, one of those plasma balls. So the image is basically a running, living environment for your objects. Now, when you start up an image, you start running some Smalltalk and you create an object, it just lives in this image. When you close your program down, your objects actually serialize straight to disk. And the cool part is when you bring your program back up, the objects just pop back to life. There is no query language to some external service. So I think that that's a really interesting way to think about persistence. So back in 2007, Avi Bryant gave a keynote at RailsConf. And what he said was, the future of Ruby is here. It's just that we have it over in the Smalltalk world, and you guys should come and get it. I was like, wow, I don't even know what you mean by that. Because back in 2007, I'd maybe written like one blog app or something in Ruby. What he suggested was that we petition GemStone, a Portland company, builds enterprise-level Smalltalk products. They've been doing it for decades, to give us some of that magic. So this is actually, so GemStone S is a product that GemStone, the company, a little confusing, has been working on for 15, 20 years now. It's essentially a distributed Smalltalk. 30. The company has been in existence since March 1st, 1982. But yeah, they're old school, like ponytailed Smalltalk guys. They're great. So what is GemStone S? So it's a well-tuned virtual machine to run Smalltalk. It's battle-tested. It's been used by, the examples are, JP Morgan Chase uses it to do their financial modeling. National Slovenian Gas Company, they built their whole entire billing system, and they've survived all sorts of huge changes in the deregulation of the European energy market and the introduction of the VAT tax. So when I was talking to Dale last week, he asked me, he said, how much do you think about saving your data instead of using it? So that's actually the cool part of what I'm going to talk about, which is MAGLEV. MAGLEV is a Ruby implementation that runs on top of the Smalltalk, the GemStone S virtual machine. And there's a lot of power in this virtual machine. It all comes from something, I'll talk a little bit, transparent object persistence. That bit of Smalltalk that's really fantastic that we don't have in Ruby. Well, we didn't have in Ruby. So this is usually what we build when we build our web apps. We have a bunch of smiley-faced users on their phones, maybe have some front-end website, maybe some admin, any other type of back-end apps. And they talk via an API, and we store it in something like Mongo or Postgres. A lot of times what we end up building, though, because that's kind of difficult, is something a little more simple, where maybe we cut out some of the stuff and we don't have a central API. We have our apps talk directly to each other. And think of all the duplication and all the code you have to write for that. It's quite a bit. Thinking about those systems a year and a half ago, I had an aha moment. I was like, wait a minute, transparent object persistence. If all of my objects live in one space, it means I don't have to write APIs for my systems to talk to each other. This is the kind of thing you can build with MAGLEV. I like to think of that cloud as actually a warm, sticky ball of dough. Your objects just stick inside and they float around, kind of like chocolate chips when you're making cookies. So you don't have to couple your apps together using these external services. MAGLEV actually becomes your API. And it does that by this transparent object persistence. So last night, I was driving up from Portland, and there was a ton of traffic. So I was listening to some podcasts. The Ruby Rogues podcast, it was done late June, early July on domain-driven design with David Larrabee. About halfway through, Avdi Grimm, one of the rogues, says this quote, and I'll read it for you. It's a little long. I've often wished that I could just do something where I just change a bunch of models, and at the end of the request cycle, something magical goes through and collects up all the models that I have changed and persists them. And I haven't really gotten to that level yet. Sometimes I feel that Active Record is holding me back. I could not believe that he said that. Like, I didn't throw up my hands. I wanted to because I was driving. And I was like, we have that. We have exactly what you just asked for. We've actually had it since Halloween. But MAGLEV has been worked on for quite a bit. Now, of course, there's a punchline to this, right? So what was the following comment from David Larrabee? Well, you can have that. You just have to switch to Java or .NET. And I was like, seriously? No, you don't. I mean, that's a world of hurt right there. Luckily, we don't have to enter into that world. So MAGLEV has the idea of this transparent object persistence. It's all based off of that persistent root. Basically what that is a hash. You have keys, just like a Ruby hash, you can put anything in it, symbols, strings, and then you have a value that's tacked on. So if we look at a simple example, I think you'll kind of get what I'm talking about. So ignore the abort and the commit real quick. What I've done is I've created an object. You see that it has an object ID, of course, and I tack it onto the Jesse key of the persistent root. Now in a totally different instance of my application running, I can say, hey, let's get a fresh view, and my object is just there. That's pretty powerful. So what's actually happening here? So GemStone S has a notion of a stone. The stone is where your data, your objects are actually persisted. And then you have, confusingly, what they call gems, which are instances of your Ruby program. And they could be running on the same machine. They can be running on thousands of different machines. Doesn't really matter. As long as they're connected to the stone, they will see the same information. So GemStone S is actually ACID transaction-based. So in order for one virtual machine, I'll call it a gem, one running gem, to get a snapshot of the data that's been stored at that time, you say, okay, let's abort a transaction. That gets a fresh view of the data. Now you can make any changes you want, and all you have to say is commit transaction. And all the nice stuff that we expect with, ACID and durability and consistency, it's all taken care of for us. All of a sudden, our changes are up in the stone. And any other VM that connects, once it aborts, it'll see those changes. So now there's something in GemStone S and in MAGLEV called persistence by reachability. So the notion of persistence by reachability is that I don't have to persist every object in my graph. So let's look at a really simple graph. I have this class called a cat collection, right? And right now, the cat collection is holding my cat Pierre. Now notice that I'm actually I'm persisting the collection itself. Whoa, that was wrong. Sorry about that. I hit the wrong button. Okay. I will make sure not to hit end anymore. So on another VM, you can see that I abort the transaction, and I grab the persisted cats. And the first one, like you'd expect out of just any normal array, is Pierre. I didn't persist Pierre. I persisted the collection that Pierre was in. But he was persisted also. That's persistent by reachability. So now I can also persist things that are related to Pierre himself. He likes toys. Really, he just likes balls of yarn. So there we go. We give him a ball of yarn, and he's in there. The next time an app fires up, persistence by reachability, we get that ball of yarn back. So let's talk about data structures for a second. What can we easily persist today using the databases that we use? You got arrays, basically relations, sets, relations with constraints, hashes, Postgres is HStore, that's pretty cool, Mongo, counters, maybe you got to lock a table. Suppose you could use Redis for that. Sorted sets, now you're kind of running into constraints and ordering maybe. Well, what if your app has something more exotic? Something like a KD tree or a Bloom filter? What if you mess around with Judy arrays or leftist trees? Anything that you come up with can be persisted. You can persist procs. You can persist bindings. That's pretty interesting. You can't persist in I/O, but you don't really want to anyway. There's a few things that you wouldn't want to persist. So I'm going to run through a blog I whipped up this morning, literally this morning. Basic Sinatra application. I grab the blog out of the hash, and then I grab all the posts. This could be normal active record stuff. When I want to look at a post, I'm just using the object ID as the ID. It kind of makes sense, doesn't really matter. So that looks pretty simple. That's my query. There is no SQL, there is no JavaScript, there's no nothing else. It's just Ruby. When I want to add a post, okay, post.class is nasty, I know. This was done quickly. Again, I can just create a post. I can tack it on to the posts of the blog, and it's just saved. It's just persisted. Now it's persisted using this MAGLEV transaction wrapper, which is actually in the MAGLEV repository. And you can see all it really does is if the status comes back 200 to 399, something that wasn't a failure, let's commit the transaction. We always abort coming in, and then we make a decision whether or not we want to commit on the way out. Well, that's pretty simple. That's exactly what Avdi was talking about. That's exactly what he wants. And like it's one rack middleware. It's pretty slick. So now let's look at the MAGLEV blog itself. It's a PORO. It's a plain old Ruby object. Hate that. It's just Ruby, okay? Just as you'd expect. You got a post. There are no fields in a database. There's no, saying what the type is with Mongoid. Same thing with authors. Extend it to comments, all that kind of stuff. And the way I bootstrapped this was I had this little script that said, hey, MAGLEV, persistently load the file so that in the future, all of my posts and my authors can be committed, can be persisted, and then commit it. And there we go. I had a blog. No external database, and it actually works. So let's talk about something a little more useful than my shitty little blog. Background jobs. Last year, I kind of did a quick spike on a background job processor in MAGLEV. So this is kind of what we'd think of as our background processing queues, right? You have some type of collection. We want to put something into it, and later we want to call. So let's do that in MAGLEV. We abort a transaction. We set an array. We push procs into the array. And then we commit the transaction. We do that over and over again. There's our background job processor. That's the producer, sorry. That's not the actual processor. But that's pretty simple, right? On the worker side, this could be an instance of the program running on a totally different machine. All we have to do is abort the transaction, grab the first thing out of the array, commit the transaction, call work. That's it. Now, there's a few issues with this. One, what happens if the commit fails? What happens if two instances actually grab the same job? Also, that arrays, as they're built into GemStone S, aren't concurrent data structures. And I'm sure there are other issues with this, but those are the two fun ones. So we can simply rescue this commit failed transaction. That takes care of adding stuff in. This is the producer. Oops, sorry. On the consumer side, we do the same thing. We say, hey, if somebody's already grabbed this job, then let's just try again. Let's just redo. That's super simple, right? So we've taken care of what happens if a commit fails. So now, arrays aren't concurrent data structures. Well, GemStone has a notion of concurrent data structures. There's 4 of them. There's Smalltalk versions. These are the Ruby versions. They're called reduced conflict classes. So we have a hash, a queue, a counter, and then something called an identity bag, which is a Smalltalk thing. We don't really use those. Counter and identity bag are not actually exposed right now, but hash and queue are. So what are these reduced conflict classes? Well, if we think about a reduced conflict hash, it's the big hexagon. Every client that connects to, wants to write to it, it gets its own little hash. That's where it writes. But anytime it reads, it's reading from the sum total. So this allows us to write as much as we want to this data structure, and then when we read it, it's the sum total. So we can use the queue for that, reduced conflict queue. Now we've got a concurrent data structure, and it's exposed. It works pretty much the same way as the array. So we've taken care of that, and you can see a little bit more here. Grab it out of the show notes. There's no show notes. I don't know what I'm talking about. But what's the point? The point is that this was 34 lines of Ruby code. That's including something that clears it, okay? If we're getting paid peanuts, was it $56,000 a year? Hopefully we get paid more than that. This maybe would cost an employer, let's say, $2,000, $3,000. Okay, you probably cost more than that just to implement Rescue or maintain Sidekick. Don't get me wrong, I love those libraries. They're great. So, MAGLEV as it stands now, targets 187. Passes a whole bunch of Ruby specs, but it still needs some help to pass more Ruby specs to really get it up to 187. It does run some C extensions, but because it's largely based on Smalltalk, there's quite a bit of work to get some of the C extensions to work. There's things like rspecs described class. We need to figure out why that's not working. And I/O right now is not quite exposed, but it is, but there's some love that needs there. But it does run things that we depend on. Nokogiri will install. It's a special version, but it will install. bcrypt will install. JSON will install. You can use these libraries. So really, there's no reason, at least not to play around with MAGLEV. So what's the future of MAGLEV? Well, I hope that it's bright. I hope that people use it, turn to love it. Soon, GemStone will be releasing GemStone S3101. Right now, MAGLEV is based on the 3.10 virtual machine. There's some known issues with that. So the 3.101 release will address those. And that should be coming out pretty soon. HPI, the institute in Germany, they have a class project to get enough 1.9 running. Okay, let me back up for a second. Hopefully the students will pick, and most likely 6 to 8 of them are, picking to work on MAGLEV in order to get enough 1.9 running to run Rails 4. So that's pretty cool. That means you guys will actually be able to stay in your Rails environment, use most things, use some of the 1.9 syntax to be able to build some apps. I would love to see what you guys come up with. Okay, the blog example, pretty cheap, but it worked. The queue example, kind of slick. For shits and giggles last year, I started re-implementing Redis. Because if you think about it, Redis is just a dumbed-down version of MAGLEV. API is just strings as keys. And that's up on my GitHub. You can check it out. I think there's some really cool things we can do. It's easy to install MAGLEV, RVM, Ruby build, if there's, and then you can just install it from the install.sh script in the repo. I think I got a couple minutes for questions if anybody has any. Yeah, way in the back. Hi. I don't know if you did this on purpose, but I would like you to comment on the speed. You, sorry? I'd like you to comment on the speed of MAGLEV. Oh, the performance of MAGLEV. So the question was, what's the speed of MAGLEV? I was going to include benchmarks, and I had the slides all written out and everything, and then I decided not to. It is perfectly fast enough. Okay? What do I mean by that? So I ran the KD tree examples in the repo, and it, of course, outperformed 187. In cases, it outperformed 193. And I didn't compare it against JRuby, but it also did pretty well against Rubinius. I think there's been very little to no work done on performance, and it keeps up quite well. Besides just that, it has transparent object persistence, which, while it may not run your code really fast, it will probably save you time in other places.
Maybe it's a naive benchmark, but in the benchmark directory, there's the pstore example, and it was 8 times faster than 1920 or 180. It was screamingly fast.
Yeah.
Against an actual persistence example.
Yeah.
And I think it should be said that there's 30 years of VM optimizations in the VM behind MAGLEV, and they know how to use this stuff.
Yeah.
Really well. These are experts in the field of optimization of VM.
Yeah, Alan Otis, he's
One of the smartest people I've ever worked with.
yeah, he's incredible. Like, he's really easy to talk to. He's somebody who's been implementing really fast small. Like, you guys know that Java's fast because small talk, right? Like, the strong talk optimizations. I don't know a lot about it. I do know that, right? Java's fast because of research done to make small talk fast. Small talk is fast enough, and like Avi said back in 2007, there's no reason why Ruby can't be running as fast as Smalltalk. It's basically the same language.
How does it handle the persistence? So once it sort of sends it to the persistence store, the stone, like you said?
Yeah.
How does it make sure that that's durable?
So how does GemStone S make sure that your data is durable? I don't know the exact. Okay, so every transaction that comes in, there's a log written to the transaction log. They've been doing it for so long. I don't know the internals of the virtual machine. It just does. Yes?
So the last time I remember looking at MAGLEV, which was years ago, I thought I remember the catch being that the distributed storage in the background costs money once you want to use it for anything not playable.
Right.
So what, is that true still? And how much? I remember it's one of those like contact us.
Yeah, but that was probably, I don't even know, I'm not sure when that was. On the Seaside website, they have they show some of the tiered examples. The community version, you can store as many objects as you want. It's just not all of them will fit in a memory. On the community version, you can use, I believe, 2 CPUs, and you can have 2 gigs of what's called the shared page cache. And that's kind of the in-memory pool that your objects can fit into. So if you think about 2 gigs of objects, that's a lot of objects. And those are just the ones that fit into memory. Any of them that don't get used or don't get used as often will get persisted to disk and then pulled back out when necessary.
Right, once you pass that point, you're kind of at the mercy of whatever they want to charge you.
You know, I suppose, but I would like to see somebody build an app that gets past that point. Monty at GemStone, you know, when I asked him about that, he said that JP Morgan Chase, they pretty much don't go over the 2 gig shared page cache. Shared page cache. Are we out of time? Okay, thank you.